Alright guys, today's goal, the learner will understand how to solve equations with variable on both sides. Alright, so this is where it can get a little tricky, and here's the thing, you can do it either way, but if you want to try to keep it so you don't have to worry about the negatives as much, step one is to identify which one is smaller, negative 2x or negative 3x, okay? Because you want to move the smaller one. So think about negatives. Would you rather owe $2 or owe $3? Well, I'd rather owe $2, so that must be the bigger one. So here's the smaller. So how do I get rid of minus 3x? I add it over to the other side. Do you see how I'm lining them up? Line them up, okay? Now negative 3 plus 3 is 0. Bring down your 9. Bring down your 17. Negative 2 plus 3 is 1. How do I get rid of the 17 now? I subtract. So I get x equals negative 8. Okay? And now watch. If I did it the other way, you'd end up with the same thing, but just watch. Add the 2x. You get 9 minus x equals 17. If I subtract the 9, I get negative x equals 8. Divided by the negative 1, you get x equals negative 8. So see how there is that little extra step because we had to divide by the negative? It's okay, but try to focus on always moving the smaller variable first, okay? Let's take a look at some more examples. Okay. So here. So before we move anything, see how we have this set up where we have to distribute? So let's distribute first because it's just whole numbers. So you have 5z minus 2 equals 6z minus 8, because 2 times 3 is 6, 2 times 4 is 8. Now which one's smaller? The 5. So I'm going to subtract the 5z. You get negative 2 equals z minus 8. Add the 8. You get 6 equals z. Okay? Let's look at another one. Alright, now, this is the tricky one here. Okay? And I'm going to copy this down so we have a little more room to see what I'm about to do. Okay? So we have 8y minus 6 equals 2/3 times 6y plus 15. So remember, the last time in the notes I said you should just try to, since it's a fraction, you should just try to multiply by the reciprocal. So what we need to check, remember, is, so there's two options here. And I'll go over both. If I were to distribute this, what's 6 divided by 3? It's 2. What's 15 divided by 3? It's 5. So see how both of these are divisible by 3? So you could distribute if you want. Or the other way would be to multiply by 3 over 2 on both sides. Okay, so what we'd have to do is look. Okay, 8 divided by 2, 4, 6 divided by 2, 3. Okay, so it doesn't matter which way you do it here. Okay, if you ever distribute and it doesn't get you a whole number, then try to do the reciprocal, and we might as well do that now. Because this cancels to be 1, so I'm left with 6y plus 15. Here I'd have, now remember, you go 8 times 3 is 24, and then you have the 2, or you cancel. And what's 3 times 4? 12. Now the only thing you got to worry about canceling here is you have to erase this for the 6 now. Because what's 6 divided by, well, 2 goes into 2 once and goes into that 3. But it's not canceled for both, okay? And then 3 times 3 is 9. Now which one's smaller, 12 or 6? The 6. So subtract the 6. You get 6y minus 9, bring it down. That's 0, bring down the 15. Add the 9. Divide by 6, you get y equals 4. Okay? So let's take a look at a couple more examples, but that's the most challenging one, so make sure you understand it. If you need to, rewatch. Okay? Alright, a car dealership sold 50 new cars and 67 used cars this year. The number of new cars sold at the dealership is increasing by 6 cars each year, and the number of used cars is sold has decreased by 4 cars each year. If these trends continue, how long will it take for the new cars to be double the used cars sold? Okay. So right now, the new cars is, you're selling 50 new cars, but it's increasing by 6 per year. So plus 6 times the number of years it's been. And we want that to be double, which means 2, and then parentheses. The 67 used cars, but they're decreasing by 4 each year. Okay? So distribute out the 2. Copy this down. Okay, so 2 times 67, 134. I'm going to double check that to be safe. Yep. 134 minus 8y. Now this is where another tricky example. So what do you think is smaller, 6y or negative 8y? See, that's what you have to remember. It's the negative. Anytime you see that, just add it over. So you have 50 plus 14y equals 134. I'm going to give us some more room to write. Subtract the 50. You get 14y equals 84. Divide by 14. You get y equals 6. And don't forget to give me what? 6 years. That's why I use the y. Okay? So hopefully we're starting to see these. I know the word problems can be difficult, but we'll knock them down, guys. Let's keep going. All right, now comes so number of solutions. Okay, these can be interesting. So let's see what happens. It says equations do not always have one solution. An equation that is true for all values of a variable is an identity. So the solution of the identity is all real numbers. Some equations have no solution. So let's see what happens here. Distribute the 9. You get 9x plus 12 equals 9x plus 12. Now you should see, there's something going on here. Oh, sorry. Not 12. 9 times 3, not 12. What's 9 times 3? 27. I was just getting so excited I thought it was going to be something else. So they're not the same right now. So what do? They're both the same. Like, which one's smaller, 9 or 9? They're the exact same, so just subtract it. You get 12 equals 27. Is that true? If you think 12 equals 27, I'll trade you $12 for $27 and we're even. Okay? No, it's not. So see how this was a false statement? That means no solution, which is also a symbol of this. No solution. Okay? So there's an example right there where you have no solution. Okay? So let's look at this one. Well, this one, I'm going to have to create one right here that we'll all have to handwrite, because this one is just, you get 1 equals w plus 1, subtract 1, you get w equals 0. Okay. So I must have missed or mistyped or something there, but let's just do an example here. So get ready to copy this down, okay? If I have 3 times the quantity x plus 2 equals 3x plus 6. Okay? Remember, we distribute out the 3. You have 3x plus 6 equals 3x plus 6. See how they look the same here? Well, if I subtract the 3x, this time I get 6 equals 6. Is that true? Yes. $6 does equal $6. So this is when the answer is all real numbers. Okay? Sorry about that, guys. I must have mistyped. I'll have to remember to change that. Well, we'll see you in class.